the product rule. In the same way that multiplication is just repeated addition, the product rule is simply a repeated application of the sum rule. It is used to count the number of ways to perform a series of successive operations that are independent of one another. Okay, here's an example. You're at a bubble tea shop, okay, and you're buying drinks for yourself and 6 other friends from your study group. There are only 3 drink options at this place. Not that many. They have oolong milk tea, they have a honey green milk tea, and they have a taro milk tea. Also, only 2 toppings are available. You can get pearls, you can get pudding, and you can also choose not to have any toppings on your drink. Now, assuming each drink can have at most 1 topping, the question is, are there enough drink combinations so that each person in your study group gets a different drink? Okay, so that's the question here. And I'd like for you to pause the video now and try this problem yourselves. Okay, so how did you approach this problem? Did you try maybe listing everything? If you did, you would have found 9 combinations. And they're listed here. Oolong, oolong and pearls, oolong and pudding, and so on. So the answer is yes. There are 9 different possible drinks that are different that you can make from this bubble tea shop. And you're buying 7 drinks, right? So that's basically enough. So each of you gets a distinct drink. Now, when you were doing this, maybe you tried the sum rule as well, right? So what does the sum rule say? The sum rule says, well, you just need a partition of the collection of the objects you're counting, right, into distinct sets. And so you can also think about it in this manner where every drink falls into exactly one of these 3 cases, oolong, green, or taro, depending on the base drink that you start with. Right? So we can partition all the combinations into one of these 3 sets. Then simply count the number in each individual set. So for instance, starting from oolong as the base drink, there are 3 possibilities, right? It's either you have an oolong milk tea with no topping, you can have it with pearls, and you can have it with pudding. And in fact, if we call these your sets B1, B2, and B3 from our sum rule definition, then you would see here that the cardinality of B1 is 3, the cardinality of B2 is 3, and the cardinality of B3 is also 3. And the sum rule says, well, let's just add all of them up to get the number. And you get 9 possible drink combinations, which is, well, the same answer that we got from listing. But now observe that it really didn't matter what the base drink was. Regardless of what you started with, you would have had the same 3 possible options for toppings. Either no topping at all, pearls in your drink, or pudding in your drink. Which means, really, you could have just multiplied 3, which is the number of sets in the partition, by 3, which is the cardinality of each set, to get the total. And really, that's what the product rule says here. Since the choice for toppings is an independent option or an independent choice for you to make, right? Regardless of the drinks that you have, then you simply have to multiply, well, 3 ways to pick a drink times 3 ways to select or not select the topping, giving you 9. Right? So you can visualize it as follows. Step 1, pick a drink. There are 3 ways. Step 2, pick a topping. There are 3 possibilities. We can even visualize this as a tree. So your first decision here would be to pick from among the 3 possible base drinks. Oolong, honey green, or taro milk tea. And for each of these options, you can get no topping, you can get pearls, you can get pudding. 3 here and 3 here. And there are a total of 9 possible paths from the 3, right? From left to right. So 3 multiplied by 3 in the second level gives you 9. And that's the product rule. And in full generality, here's what the product rule statement is. If you have a certain operation that takes k steps to accomplish, and if there are r sub 1 ways of performing the first step, r sub 2 ways of performing the second step, and this is important regardless of how step 1 was performed, r 3 ways of performing step 3 regardless of how step 2 was performed, and so on, then completing the operation well, how many ways can we do it? Or R1 times R2 times R3 all the way to Rn. Or we can write this product notation, product of all Ri from I equals 1 to n. Ways to do so. And that's the product rule.